Welcome to the lecture on signals and systems. We are discussing about operation on signals, and this session we will be discussing about time shifting. In the earlier video, we have discussed about time reversal operation, and this video we will be discussing about the time shifting operation. Now, as you can see here, what is time shifting? Suppose we have a signal called x of t. Now, when I say x of t, that means a continuous time signal. And when I say x of n, then that means a discrete time signal. So, suppose that we have a signal called x of t and we define a new signal by adding or subtracting a finite time value to or from it. We will now have a new signal called y of t, and the mathematical expression for this would be called as x of t minus t naught or x of t plus t naught. Graphically, this kind of signal operation will result in a positive or a negative shift of the signal along the time axis. Time axis, when I say, I mean the x-axis. However, we will have to note that while doing so, none of the characteristics of the signal are altered. So this actually means that time shifting operation results in the change of just positioning of the signal without affecting its amplitude values. So let us consider the examples of the signals which I have shown in the following figure. Now this first figure I have defined as a signal called x of t, and this is defined for a time period of -2 to +2, and this is having an amplitude of +1. So we will see what is meant by x of t minus t naught. So when I say x of t minus t naught, then this is a delayed signal. So to create a delayed signal, we have to shift the entire signal. Note down, we should not change the amplitude. We are not going to change the shape of the signal. Everything is going to retain just like how it was in the input. We are just going to glide the signal along x-axis. We are just going to move the signal along x-axis. So if you want to create a signal delayed, meaning a time delayed signal, then what you have to do is simply shift the signal to the right. So move the signal to the right, shift the signal to the right without changing its shape or amplitude. So earlier, if you can see, my signal starts from -2 to +2. So here I have given you a simple depiction to show whether you'll have to move it to the right or whether you'll have to move it to the left to create a delayed signal. In further examples, we will see exactly with respect to the time values. So as you can see here, this center parted signal is shifted to the right side without altering its shape. So here we have created a delayed signal. So delaying in the sense, suppose for example, if we have to go to a place by 10 o'clock in the morning, and if we arrive to the place at 11 in the morning, meaning 1 hour delayed. So that is what we are actually depicting here. The signal arrives late. It has to arrive at -2, but now it has arrived at t naught minus 2, 2 time units delayed, or t naught time units delayed, however it is depicted as. So to create a delayed signal, shift to the right. To create an advanced signal, shift to the left. So as you can see, the signal characteristics are not altered. The shape is retained, the amplitude is retained. We have simply glided the signal towards the right, towards the left side. So this will create a signal called x of t plus t naught, which is called advanced signal. This will show you another example of time shift. So replacing a t with t minus t1 will give you a delayed signal. So initially the signal is called x of t. So x of t minus 1 is depicted here. So x of t minus 1 in the sense we are delaying it by 1 time unit. Initially, if you can see, the signal starts from minus 1 and it ends at plus 1. So 1 time unit, the starting point of the signal is minus 1, the ending point of the signal is plus 1. So you'll have to shift 1 time unit to create x of t minus 1. So which side you'll have to move? You'll have to move it to the right side. So minus 1 to 0 will create 1 time shift. So your signal now starts from 1 and it ends at 2. Remember, the amplitude still remains as plus 2 as it is given in x of t, and the shape of the signal is also retained. Similarly, to create x of t plus 1, we will have to shift 1 time unit to the left side. So if you can see here, minus 1 to plus 1 has moved between minus 2 to 0. So if you can see here, minus 2 to 0. So this is 1 time unit shift to the right side. In simple words, x of t minus 1 means 1 minute late the signal is arriving. X of t plus 1 minute earlier the signal is arriving. So minus 1 earlier in the sense it arrives at minus 2. Late in the sense it arrives at 0. As you can see in this particular slide, you could see an example of a DT signal. So this is a DT signal depiction. If you can see, I've represented it as x of n, and the amplitude values are marked up as zeros, ones, twos, 1 and then again zeros. Similar to the CT signal example, x of n is your discrete time signal. X of n minus n1 will create a delayed signal. X of n plus n1 will create an advanced signal. It is of the same type what we'll have to do. X of n minus 1 delayed signal, simply move the entire signal to the right side. To create x of n plus 1, simply move the entire signal to the left side. So as you can see, minus 1, 0 and 1. Please note down these points. At minus 1, your amplitude is 1. At 0, your amplitude is 2. At 1, your amplitude is 1. So we are shifting x of n minus 1. We are shifting 1 time unit. So minus 1 will be now depicted at 0, which is nothing but 1 time unit. So every particular instant of time will appear 1 time unit late. So minus 1 value is 1. So now you can see 0 is plotted at an amplitude of 1. Then your next amplitude value is 2, depicted at 1. Then the next amplitude value is 1, depicted at 2. So simply glide the signal 1 time unit to the right side. To create an advanced signal x of n plus 1, simply glide the entire signal towards your left side for 1 time unit. So now your amplitudes are, at minus 2 your amplitude is 1, at minus 1 your amplitude is 2, at 0 your amplitude is 1. So this is a simple depiction of x of n plus 1, x of n minus 1, x of t plus 1 and x of t minus 1. Where in all the examples we have seen, we have used 1 time unit as shift. Either we have delayed or advanced. This will continue with the same time shifts of x of n plus 2, x of n minus 2, x of n plus 3 and x of n minus 3, where you will shift 2 or 3 time units respectively. Let us see a particular example. We have a CT signal represented here. So the signal what we have starts at 1 and it ends at 2, and the amplitude of this particular signal is 1. So what we have to create is x of t minus 2. So x of t minus 2 in the sense it is a delayed signal. So delayed signal means we will have to shift or we'll have to glide the entire signal to right side without changing its shape or amplitude. So it starts at 1. It ends at 2. So what you have to do, you have to shift 2 time units. So 1 to 2 means 1 shift, 2 to 3 means the second shift. So now your signal will start from 3 and it will end at 4. The amplitude still remains as 1. To create x of t plus 3 signal, we will have to shift this particular given signal x of t 3 time units to the left side. So this will create an advanced signal. So as you can see, the signal starts at 1 and it ends at 2. What if the signal arrives 3 time units earlier than it is represented here? So 3 time units in the sense 1 to 0 will count 1 time unit. 0 to -1 will count second time unit. -1 to 2 will count this third time unit. So your starting point 1 has now shifted to starting point of -2. Similarly, look at the ending point 2. We will have to count 3 time units towards the left side. So 3 time units, 2 to 1. So that is first shift. 1 to 0 is second shift. 0 to -1 is third shift. So as you can see, your entire time period has been shifted to -2 to -1. Let us have one more example here. We have created x of t minus 2 and x of t plus 3. Similarly, let us see how to create x of minus t plus 2 and x of minus t minus 2. So what we'll have to note down here is, initially the signal was x of t, and from this particular signal we have created x of t minus 2 and x of t plus 3. Now if you can see here, this is plus t. So we have used x of t as your reference signal, and from this reference signal we have glided 2 shifts right side or 3 shifts left side to create x of t minus 2 and x of t plus 3 respectively. So the next given question is, you will have to calculate x of minus t plus 2 and x of minus t minus 2. So if you can see, this is x of minus t. So the reference signal which you will have to use here to shift is x of minus t and not x of t. So how to create x of minus t? So as we have already seen in the previous video, this is nothing but a time reversal signal. So to create a time reversal signal, what you will have to do? You will have to fold your entire graph about y-axis, simply like folding your book. So by which means you will create x of minus t, a reversal signal. So now your x of minus t, your reversal signal, starts from -2, ends at -1. So keeping this as your reference signal, we will now create x of minus t plus 2 and x of minus t minus 2. So x of minus t plus 2. So to create this signal, we will have to shift this entire signal x of minus t towards right side. So right side in the sense, we will have to shift for 2 time units. So as you can see, -2 to -1 counts 1 shift. -1 to 0 counts the second shift. So your signal starts at 0 and it ends at +1. Similarly, to create x of minus t minus 2 signal, you will have to shift this x of minus t signal, or you will have to glide this x of minus t signal towards your left side. So left side, you will have to get 2 shifts, as we have seen here. This is t plus -2. So 2 time units to the left side. So if you can see here, -2. We will see where does the signal exactly start now in your new signal. -2 to -3 counts 1 shift. -3 to -4 will count second shift. So now exactly your signal starts at -4 and it ends at -3. So this is an example of CT signal I have shown here. Similarly, we will see an example with DT signal, which is quite simple as how we have seen CT signal. So this is your given DT signal. Kindly observe the signal so that you will be able to understand x of n minus 2 and x of n plus 4. So if you can see here, I have marked the amplitude values for time values of n is equal to 0 to n is equal to 3. And the respective amplitude values are 1, 2, 3, 4. That is, x of 0 is 1, x of 1 is 2, x of 2 is 3, and x of 3 is 4. So what you will have to do, you will have to create a signal called x of n minus 2. This is a delayed signal, so simply shift your entire signal towards right side. So here, remember, we are not going to alter the amplitudes, we are just going to glide the signal. So changes will happen only in the x-axis and not in the y-axis. Neither the signal shape or structure is never going to get altered. So we'll have to give 2 time units shift. So the signal starts at 0, the signal ends at 3. So let's do for the starting point. 0 to 1 makes one shift, 1 to 2 makes second shift. So now your signal will start at 2 instead of 0. I've marked the same amplitude values as 1, 2, 3, 4 respectively. Look at the ending point. Ending point is now here at plus 3. So give 2 time units for that. 3 to 4 counts one shift, 4 to 5 counts second shift. So your signal ends at 5. So we have shifted the entire signal, meaning we have moved the entire signal towards right side to create a delayed signal called x of n minus 2. Similarly, to create a signal called x of n plus 4, you will have to shift the entire signal towards the left side to the respective time shift value. So the time shift value here is mentioned as plus 4. So let us see here. Your signal starts at 0. So let's count the starting point of your new signal. Give 4 shifts, 0 to minus 1. Let me tell you with this particular place. 0 to minus 1, 1 shift. Minus 1 to minus 2 is second shift. Minus 2 to minus 3 is third shift. Minus 3 to minus 4 is fourth shift. So 0 has now shifted to minus 4. So where I mark the same amplitude value called 1. Let's check for the ending point. We have it as 3. Your ending point is 3. So let's check how does it end for n plus 4. So 3, we'll have to make 4 shifts. 3 to 2, first shift. 2 to 1, second shift. 1 to 0, third shift. 0 to minus 1 will be fourth shift. So as you can see, your ending point, which was 3 earlier, now it has become minus 1. Similarly, we will see how to create signals called x of minus n plus 2 and x of minus n minus 2. Now, as I have told you in the CT signal, the same rule applies here. Because we have found out x of n minus 2 and x of n plus 4, where it is positive value of n, we have used the reference signal as x of n. Here, if you can see, the question is you will have to find out x of minus n plus 2 and x of minus n minus 2. You can clearly see that it is x of minus n. So the reference signal what you will have to use here is x of minus n signal. So from x of n, create x of minus n signal using time reversal operation. So time reversal operation will fold your entire signal about y-axis, just like folding your notebook. So whatever is lying on this side of your graph will go and stick to the other side of your graph, just like a mirror image. So now as you can see, your new signal x of 0 has a value of 1, x of minus 1 has a value of 2, x of minus 2 has a value of 3, x of minus 3 has a value of 4. So using this as your reference signal, let us create x of minus n plus 2 and x of minus n minus 2. So to create x of minus n plus 2, you will have to shift your entire signal, glide your entire signal towards right side for 2 time units. So minus 3 is your starting point, 0 is your ending point. Let's see here. Give it 2 time shifts. Minus 3 to minus 2 is 1 time unit. Minus 2 to minus 1 is second time unit. So 2 shifts. So now your signal should start from minus 1. So as you can see here, we have started from minus 1. Let's check the ending point. 0 is your ending point here. So give 2 time units towards the right side. 0 to 1 counts 1. 1 to 2 counts second shift. So now your signal ends at 2. Remember, I have marked the same amplitude values 4, 3, 2, 1 respectively as it is given in x of minus n. I've only changed the x values. I've never changed the y values. I've only changed the time values. I've never changed the amplitude values. Similarly, to create x of minus n minus 2 signal, use x of minus n as your reference and move your signal towards the left side for 2 time units. So as you can see here, the starting point is minus 3. Let's check for the new signal. 2 time units to the left side. So minus 3 to minus 2, minus 2 to minus 1. So I'm sorry. So this is minus 3 to minus 4, minus 4 to minus 5. So now your new signal will start at minus 5. So your signal has now started from minus 5, which has the same amplitude value called 4. Let's check for the ending point 0, 2 time units to the left side. So 0 to minus 1 to 2. So do you have 2 time shifts here? So now your ending point is minus 2. So 4, 3, 2, 1 are your amplitude values. So that's how you will have to do time shifting, which is quite simple. So the assignment for this particular session would be, you will have to just sketch the following signals: u of minus t plus 2, r of minus t plus 3, u of n plus 1, r of n minus 4, u of minus n plus 4, r of t plus 2. So where u of t, r of t, u of n represents continuous time unit step, continuous time unit ramp, discrete time step functions respectively. So these are your basic signals called unit. This is your unit step signal, discrete time signal. This is your unit step continuous time signal. This is your unit ramp for CT. This is your ramp signal for DT. So make use of your standard signals and perform the shifting operations to obtain the answers for this. Your second question is, you'll have to sketch the following signal. Given is a CT signal, and for this particular CT signal, you'll have to sketch x of t minus 1. Next, as you can see here, in the given picture, we have a rectangular pulse shown here, and the amplitude and the time durations are mentioned here, which is minus 1 by 2 to plus 1 by 2 is your time duration, and your amplitude is plus 1. Your question is, you will have to find out y of t is equal to x of t minus 2. So your question here is, you will have to find x of t minus 2, and your output signal we will now call it as y of t. Your fourth question for this particular assignment is, a discrete time signal x of n is shown below. So this you call it as x of n. So from this particular reference signal called x of n, you will have to sketch two different signals, x of n minus 2 and x of n minus 3. This is simply as how I have shown you in the example. So learn the example once again and complete the assignment. Complete the assignment before the stipulated time period. In our next video, we will see time scaling operation. Thank you.